Right now, more than 15 billion miles from where you are sitting, a 12-inch gold-plated copper disc is moving through the dark at 38,000 miles an hour. It carries greetings in 55 languages, the sound of a mother's first words to her newborn son, whale songs, thunderstorms, a Bulgarian folk tune, and the brainwaves of a young woman in love, encoded as static. No living person will ever touch it again. It is headed nowhere in particular, toward no star, on no timeline that any human being will live to see completed. And yet, it may be the longest-lasting artifact our species ever makes. Longer than the pyramids, longer than language, longer, very possibly, than Earth itself. This is the story of the Voyager Golden Record, the strangest message ever sent, built by a handful of scientists and artists in a few frantic weeks in 1977, who had to answer an impossible question. If you could speak to the universe only once and never hear back, what would you say? If you enjoy stories about the strange, beautiful, and slightly absurd corners of space history that most people never hear about, consider tapping that like and subscribe button. It genuinely helps this channel keep going, and I appreciate every one of you for being here. Now, let's begin. In the summer of 1977, two NASA spacecraft left Earth within 16 days of each other. Voyager 2 launched first on August 20th, followed by Voyager 1 on September 5th, its trajectory designed to overtake its twin and reach Jupiter first. Officially, their mission was to conduct a grand tour of the outer planets, Jupiter, Saturn, and for Voyager 2, eventually Uranus and Neptune as well, using a rare planetary alignment that occurs only once every 176 years to slingshot from world to world using gravity assists rather than fuel. That mission alone would have justified the spacecraft's existence 1,000 times over. The Voyagers returned the first close-up images of Jupiter's Great Red Spot, discovered volcanic activity on Io, found rings around Jupiter that no one had confirmed before, and later revealed the moon Europa's cracked icy shell, hinting at an ocean underneath that scientists are still trying to understand half a century later. But bolted to the side of each spacecraft, mounted like a strange ceremonial shield, was something that had nothing to do with planetary science at all. A gold-plated copper phonograph record, 12 inches across, sealed in a protective aluminum jacket, etched with diagrams that no human engineer would ever need and no Jovian moon would ever ask for. This was the Voyager Golden Record, and its job was not to study the solar system. Its job was to leave it. To survive the solar system's destruction, the death of the sun, the end of human civilization, and possibly the end of every civilization that ever existed on Earth, and to still be there, still playable, still meaningful whenever someone or something finally found it. The idea did not originate inside NASA's engineering departments. It originated almost by accident 4 years earlier, attached to a much smaller and far less ambitious spacecraft. In 1972, NASA launched Pioneer 10, the first human-made object ever sent on a trajectory that would eventually escape the solar system entirely. Pioneer 10's primary mission was to fly past Jupiter and report back on its atmosphere and radiation environment, a purely scientific objective. But the astronomer Carl Sagan, then a professor at Cornell University and already a public figure through his books and television appearances, approached NASA with a proposal. If this spacecraft was going to leave the solar system anyway, drifting silently through the galaxy for millions of years after its instruments died, why not attach something to it that explained who had built it? NASA agreed, and Sagan worked with the artist Linda Salzman Sagan, his wife at the time, to design a small gold-anodized aluminum plaque, 6 by 9 inches, engraved with a simple set of images. A drawing of a man and a woman standing beside an outline of the spacecraft for scale. A diagram of the solar system showing Pioneer's trajectory. A map of pulsars, rapidly spinning neutron stars that emit regular bursts of radiation at distinctive frequencies, used to mark Earth's location in the galaxy, with the timing pattern of each pulsar encoded so that anyone who found the plaque could calculate roughly when it was made. And a diagram of the hydrogen atom's hyperfine transition, the most common and recognizable physical phenomenon in the universe, intended as a kind of universal unit of measurement that any sufficiently advanced civilization, anywhere built on any kind of chemistry, would presumably understand. The Pioneer Plaque was minimal almost to the point of austerity. It carried perhaps a dozen distinct pieces of information. It was designed in a matter of weeks, attached almost as an afterthought, and launched on a spacecraft that nobody expected to make first contact with anyone. And yet, the moment it became public, it provoked an unexpectedly intense reaction. Some praised it as a profound gesture of cosmic humility. Others criticized the nude human figures as inappropriate for a government-funded project. A Philadelphia newspaper columnist accused NASA of sending what he called smut into space. The debate revealed something that would become central to the entire story of interstellar message-making. There is no neutral way to represent humanity. Every choice, every image, every omission says something about who gets to speak for an entire species and what they choose to say. Pioneer 11 followed in 1973, carrying an identical plaque on a trajectory that would also eventually carry it beyond the solar system. By the mid-1970s, then, humanity had already sent 2 small deliberate messages into interstellar space, tucked onto spacecraft whose primary purpose was something else entirely. When NASA began planning the Voyager missions for 1977, the question was no longer whether to include some kind of message. The question was how much further this idea could be pushed, now that there was time to plan it properly, money to fund it adequately, and a spacecraft mission profile, venturing past Saturn and beyond, into trajectories that would never return. That made the symbolism even more appropriate. NASA again turned to Carl Sagan, and this time gave him something he had never had before: months of lead time and a real budget. Sagan assembled a team that reads, in retrospect, like a deliberate experiment in interdisciplinary collaboration. Frank Drake, the radio astronomer who had founded the modern search for extraterrestrial intelligence and authored the famous equation estimating the number of communicating civilizations in the galaxy, became the project's technical lead, responsible for figuring out how the actual recording and engraving would work. Anne Druyan, a writer who would later marry Sagan, became the creative director responsible for assembling the record's audio content, including a controversial decision that we will return to later in this story. John Lomberg, a science illustrator, oversaw the selection and arrangement of the images. Timothy Ferris, a science journalist, served as the project's producer, responsible for turning all of this raw material into something that could physically exist on a record within a matter of weeks. Linda Salzman Sagan again contributed to the visual design. They had roughly 6 weeks. The Voyager launch dates were fixed by orbital mechanics, missed the planetary alignment window, and the entire mission concept, the grand tour using gravity assists, would have to be redesigned or abandoned. There was no flexibility to extend the deadline for the sake of a side project, however meaningful. The team had to decide in a matter of weeks how to represent the totality of human civilization, human culture, human biology, and human history to an audience that might not exist for millions of years, might not be human, might not even perceive sound or light the way humans do, and might never be encountered at all. The medium itself had to be chosen first, and the choice was not obvious. A phonograph record sounds almost quaint by the standards of 1977, let alone today, but it was selected deliberately for its durability and its analog simplicity. Unlike a digital storage format, which requires a specific complex piece of hardware to decode binary information into anything meaningful, an analog phonograph record encodes sound directly into a physical groove. In principle, anyone capable of building even a primitive stylus and a means of converting vibration into sound could, theoretically, extract something from the grooves without any specialized decryption. It is the same logic that makes Edison's wax cylinders from the 1880s still playable today, more than a century. Later, while floppy disks from the 1990s are already approaching unreadability for most people without specialized equipment. The team gambled that durability over geological timescales mattered more than fidelity, and that simplicity of playback mattered more than data density. The record itself was made of copper, electroplated with gold for corrosion resistance, since gold does not oxidize or tarnish even after exposure to the vacuum and radiation of deep space for spans of time that dwarf human history. It was cut using a technique that allowed both audio and image data to be encoded onto the same grooves, a method engineered specifically for this mission. Each record could hold approximately 90 minutes of material split across two sides, encoded at a rotational speed of 16 2/3 revolutions per minute, slower than a standard commercial record of the era, which allowed more content to be squeezed into the available groove space. The record was packaged in an aluminum jacket, electroplated with a small sample of pure uranium-238. This was perhaps the most quietly ingenious piece of the entire design. Uranium-238 decays at an extremely well-characterized and unchanging rate, with a half-life of approximately 4.5 billion years, coincidentally almost exactly the age of the solar system itself. Any civilization sophisticated enough to intercept the spacecraft and analyze the jacket would almost certainly understand radioactive decay, since it is one of the most fundamental and universal physical processes there is. By measuring how much of the uranium sample had decayed into its daughter isotopes, a finder could calculate, with reasonable precision, how long the record had been traveling, essentially turning the jacket itself into a built-in clock, ticking silently for however many millions or billions of years it might take for someone to find it. The cover of the jacket was engraved with instructions, and this is where Frank Drake's expertise became essential. The team needed to explain, using only symbols and diagrams, with no shared language and no possibility of clarification, exactly how to use a phonograph cartridge and stylus to play the record, what speed to rotate it at, and how to convert the encoded groove patterns back into images, since roughly a sixth of the record's content was not audio at all, but still images encoded as analog signals, similar in principle to old analog television transmission, that could be reconstructed into pictures if decoded correctly. The cover also carried, once again, the same fundamental design elements introduced on the Pioneer Plaque: the hydrogen atom diagram, establishing a baseline unit of time and length, and the pulsar map marking the location and approximate launch date of the spacecraft relative to 14 pulsars scattered through the galaxy. Their precise periods of rotation engraved as binary numbers that any sufficiently advanced mathematics could decode. With the format settled, the team turned to the much harder problem. Content. What sounds exactly represent a planet? Androyan led much of this effort, working with a team that included the writer and folklorist Alan Lomax, whose decades of work recording traditional and folk music from around the world gave the project access to recordings that might otherwise have been impossible to locate or license on a 6-week deadline. The finished record opens after a spoken greeting sequence we will return to shortly, with a section the team called The Sounds of Earth, a roughly 12-minute audio collage assembled to represent the physical and biological environment of the planet before any human voice or instrument appears. It begins with the sound of Earth's own geology and weather, volcanoes, earthquakes and rolling thunder, low-frequency rumbles meant to convey a living, geologically active world. From there, it moves into the sounds of life. Crickets, frogs and birdsong appear in sequence, woven together to suggest an ecosystem in layers, from insects through amphibians to birds. A chimpanzee's call follows, then a hyena, and the famous eerie ascending cry of a humpback whale included. Partly because Sagan and the team felt that whale song demonstrated, more powerfully than almost any other sound on Earth, that complex, structured, possibly even meaningful vocal communication was not unique to humans. The sequence then turns deliberately toward human. Technology and human life, in a chronological arc that mirrors the development of civilization itself. Footsteps and a heartbeat. Laughter. Specifically, Androyan's own laughter was used for this segment, recorded during the production process itself, a detail that gives the record an oddly intimate, almost accidental personal signature buried inside what is otherwise an attempt at universal representation. Then fire crackling, followed by the bark of a domesticated dog, the herding of sheep, the clang of a blacksmith's hammer against an anvil, the sound of a saw cutting wood, all representing the transition from natural sound to early human tool use and agriculture. The sequence accelerates into the modern era. A tractor, riveting machinery from heavy industry. The chugging rhythm of a steam locomotive followed by a more modern diesel train. The roar of a Saturn V rocket launch, the very machine that, just a few years earlier, had carried human astronauts to the moon, included here as both a literal recording and a kind of symbolic culmination, the loudest and most technologically advanced sound humanity had ever produced up to that point. The Sounds of Earth sequence closes with something deliberately strange and tender, a recording of a human heartbeat layered with brainwaves belonging to Androyan, recorded during an experimental session in which she attempted to think about the history of Earth, human civilization, and her own feelings, all converted into the kind of static, crackling audio signal that an EEG machine produces. It is, in effect, an attempt to record a single human thought and bury it on a spacecraft destined to outlive the species that thought it. The greetings sequence, which actually opens the record before the Sounds of Earth segment, was assembled with similarly careful intent. The team gathered 55 spoken greetings in 55 different languages, ranging from widely spoken languages like Mandarin Chinese, English, and Spanish, down to ancient and lesser-known tongues such as Sumerian, Akkadian, and the Nepali-related language of Newari. The greetings were not scripted to be identical across languages. Each speaker, often a graduate student or faculty member at Cornell University with native or fluent ability in a particular language, was simply asked to say something appropriate. A greeting to potential extraterrestrial listeners, in their own words, in their own language. The result is a strange chorus of sincerity. A woman speaking Mandarin says, roughly, that she hopes everyone in the universe is well. A child's voice in English, that of Sagan's own young son Nick, says simply, "Hello from the children of planet Earth," a recording that Sagan included, partly because he wanted at least one voice on the record to belong, quite literally, to the next generation, to someone who would still be alive decades later when the spacecraft was still traveling and the record was still, in theory, listening for a reply that would never come. One greeting in particular has taken on a strange second life in the decades since launch. The Akkadian greeting, recorded by a graduate student, was spoken in a language that had been extinct for roughly 2,000 years, even at the time of a recording, reconstructed from cuneiform tablets and scholarly philology. Including a dead language alongside 54 living ones was a deliberate statement. The record was not just a snapshot of humanity in 1977. It was an attempt to gesture at the entire sweep of human linguistic history, acknowledging that most of the languages ever spoken by human beings are already gone, and that whatever finds this record, however far in the future, may well be listening to a similarly extinct version of whatever languages exist when it is finally heard. After the spoken greetings and the sounds of Earth sequence, the bulk of the record's remaining runtime, nearly 90 minutes split across both sides, was devoted to music. And music turned out to be the single most contentious, most debated, and ultimately most consequential creative decision the team faced. If you only get a handful of musical selections to represent the entire history of human creativity to whatever or whoever might eventually find them, what do you choose? And on what basis do you justify leaving almost everything else out? 27 tracks made the final cut, spanning an extraordinary range of cultures, instruments, and eras, deliberately weighted to avoid the assumption that Western classical or popular music represented the pinnacle of human achievement. The selections included Indonesian gamelan music from Java, a Senegalese percussion piece, Aboriginal Australian songs, Peruvian panpipes and drums, a Navajo night chant, Zaire Pygmy Girl's initiation song, a Bulgarian shepherdess's folk song with a vocal style so distinctive that it remains, to musicologists, one of the most recognizable national vocal traditions on Earth, and a Chinese composition for the guqin, a 7-stringed zither with a written history stretching back roughly 3,000 years. Western classical music was represented as well, though selected with what the team intended as restraint rather than dominance. Compositions by a handful of European composers from the 17th through early 20th centuries appear on the record, chosen for qualities the team felt represented something close to mathematical or structural universality. Pieces built on complex counterpoint, layered harmonic structures, and intricate, almost architectural patterns of repetition and variation. The kind of formal complexity that the team hoped might translate, conceptually, even to a listener with no contextual understanding of European musical history or tradition. One particular orchestral movement, chosen for its dense, interweaving structure, was included specifically because Sagan and Druyan felt its layered complexity offered a kind of audible mathematics, a piece of music that, even stripped of cultural context, demonstrated structural sophistication in a way that might be recognizable to a sufficiently advanced listener regardless of species or sensory apparatus. Beyond European classical music, the record's most famous and most debated inclusion was a single rock and roll track, included specifically as a representation of American popular culture in the 20th century. The selection of that particular track by an electric guitarist whose music had defined an era of American teenage rebellion and energy was nearly cut entirely amid concerns from some NASA officials that rock music was inappropriate, undignified, or simply unrepresentative of humanity's serious achievements. Carl Sagan reportedly pushed hard to keep it on the record regardless, arguing that excluding an entire genre that had shaped global youth culture across multiple decades would itself be a distortion, a kind of curatorial dishonesty dressed up as good taste. He won that argument, and the track stayed. The selection process inevitably meant leaving out entire continents' worth of musical tradition, entire genres, entire centuries. The team has spoken since, in interviews conducted across the decades following launch, about specific regrets, traditions they wished they had been able to include, but simply ran out of time, licensing ability, or available recordings to access within the 6-week production window. Jon Lomberg has described the process less as a careful curatorial exercise and more as an exhausting scramble against an immovable deadline, made under conditions that left little room for the kind of exhaustive ethnomusicological survey the task arguably deserved. The team was assembling, in essence, a permanent cultural time capsule under the kind of time pressure normally reserved for a magazine deadline, not a monument intended to outlast civilization. There is one more piece of audio content buried within the music section that deserves particular attention because it represents perhaps the most quietly radical decision embedded anywhere on the record. Anne Druyan, working closely with Sagan during this period, made the choice to include a recording of her own brainwaves, mentioned earlier in the context of the Sounds of Earth sequence, recorded during a deliberate, structured meditation in which she thought in sequence about the history of Earth, the history and possible future of human civilization, and finally about her own personal feelings, specifically about falling in love with Carl Sagan, with whom she had begun a relationship only days before the recording session. The two would marry within the following year and remain married until Sagan's death in 1996. Druyan has spoken publicly, decades later, about the strange experience of knowing that an encoded representation of that exact emotional state, the early electric uncertainty of falling in love, with someone converted into raw electrical brain activity and then compressed into an analog audio signal, is now traveling through interstellar space permanently on a machine that will likely outlast every structure built by human civilization. It is, by some distance, the most personal and least universal piece of content anywhere on a record explicitly designed to represent the entirety of the human species. And yet it has become, for many people who learn the full story decades later, the single most affecting detail in the entire project. A reminder that even an effort built around grand, sweeping universality was, in the end, assembled by particular people with particular lives who could not help but leave fingerprints of their own individual existence behind. The image content, mentioned earlier as encoded directly into the analog grooves alongside the audio, comprised approximately 116 images selected and sequenced by Jon Lomberg's team to build, in effect, a visual primer on Earth, humanity, and basic physical science. The sequence opens with scientific and mathematical diagrams, a calibration circle to help a future listener understand image proportions and color correctly, followed by diagrams of the solar system, depictions of Earth's structure, DNA's double helix molecular structure, and human anatomical diagrams showing male and female bodies, including, notably, a pregnant woman, conception, and fetal development, intended to represent human biological reproduction as plainly and scientifically as possible. From there, the images move outward into human life and culture. Photographs of cities, deserts, forests, and oceans. Images of people eating, people working, families in different cultural and ethnic contexts around the world, children in a classroom, a diagram of human anatomy and the structures of human cells. Images depicting architecture from radically different traditions, from a thatched African village structure to the Taj Mahal, to the Sydney Opera House, to the United Nations headquarters building, intended to represent the diversity of human building traditions and the eventual development of international cooperative institutions. There is a photograph of a supermarket shelf stocked with food, included specifically to represent the abundance and complexity of human agricultural and distribution systems. There is an image of a violin alongside its sheet music, intended to demonstrate that the musical sounds elsewhere on the record originated from physical instruments played by human hands, following written notation systems. And then, near the very end of the image sequence, after photographs depicting astronauts, a radio telescope array, and a rocket launch, the sequence closes with a single final image. A photograph of the sunset, taken from Earth's surface, intended by Lomberg's team as a quiet, almost wistful closing note. Earth's own star, seen from the world it warms, included as the last visual statement the record makes, before falling silent for however many millions of years it might take for another set of eyes, if there are eyes at all, to ever see it again. By the time both Voyager spacecraft launched in the late summer of 1977, the Golden Record had gone from a 6-week scramble to a finished, bolted-down piece of permanent hardware mounted on the outside of each spacecraft in a protective case, wired to a stylus and cartridge that, in theory, could be deployed and used to play the record without any further intervention from Earth. NASA had no real expectation that this would ever happen. The record was less a practical communication device and more a kind of cosmic message in a bottle, thrown into an ocean so vast that the odds of it ever washing up on a relevant shore were, by any reasonable estimate, almost unimaginably small. But the spacecraft themselves had real, scientific work to do first, and that work occupied the next decade and more. Voyager 1 reached Jupiter in March 1979, returning images and data that transformed planetary science's understanding of the gas giant and its moons. It reached Saturn in November 1980, capturing detailed images of the planet's ring structure and its moon Titan, whose thick, hazy atmosphere intrigued scientists enough that decades later, in 2005, a separate probe called Huygens would be sent specifically to land on its surface. With its primary planetary mission complete, NASA made the decision to send Voyager 1 on a trajectory that would carry it up and out of the plane in which the planets orbit, sacrificing any possibility of additional planetary flybys in exchange for a faster, more direct path out of the solar system entirely. Voyager 2, launched slightly earlier but on a slower trajectory, took a different and considerably more ambitious path. It reached Jupiter in 1979, Saturn in 1981, and then, using a sequence of gravity assist maneuvers, that depended on a planetary alignment occurring only once every century and 3/4, continued onward to Uranus in January 1986 and finally to Neptune in August 1989. To this day, Voyager 2 remains the only spacecraft ever to have visited either Uranus or Neptune, and the images and data it returned during those two flybys represent, in many cases, still the only close-up information humanity possesses about either planet nearly 4 decades later. Voyager 2's images of Neptune's largest moon, Triton, revealed active geysers of nitrogen ice erupting from its surface, a discovery that reshaped scientific understanding of what kinds of geological activity were possible on small, distant, intensely cold worlds. With its planetary mission complete, Voyager 2 also turned outward, following its twin toward interstellar space, though on a different trajectory and heading toward a different region of sky. Both spacecraft entered what NASA calls their extended mission phase, continuing to send back data about the outer reaches of the solar system, using a suite of remaining instruments, even as their radioisotope thermoelectric generators, the nuclear power sources that provide their electricity, since sunlight at that distance is far too weak for solar panels to be practical, slowly are inevitably decayed. In August 2012, Voyager 1 became the first human-made object to cross the heliopause, the boundary where the Sun's outward stream of charged particles, the solar wind, is finally overwhelmed by the pressure of the interstellar medium beyond it. This crossing marked, by most scientific definitions, Voyager 1's official entry into interstellar space, no longer technically within the solar system's plasma environment, though still, by a wide margin, within the Sun's gravitational influence, which extends vastly farther outward to encompass the theorized Oort cloud of icy bodies. Voyager 2 followed, crossing its own heliopause boundary in a slightly different direction in November 2018. As of the time of this video, both spacecraft remain operational, continuing to transmit data back to Earth's deep space network using radio signals that, due to the sheer distance involved, now take more than 20 hours one way to arrive. That distance, and the implications it carries for the Golden Record specifically, deserves to be stated plainly, because it reframes everything that came before. The Golden Record is not traveling toward anything. It has no destination, no target star, no planned encounter. Both Voyager spacecraft are moving through interstellar space on trajectories determined by the gravity, assists they received decades ago during their planetary flybys, drifting now essentially in straight lines, give or take the gentle, almost imperceptible influence of the galaxy's overall gravitational field. Voyager 1 is heading in the general direction of the constellation Ophiuchus. In roughly 40,000 years, it will pass within 1.6 light-years of a star called Gliese 445, not a close encounter by any meaningful astronomical standard, but the closest approach to any star the spacecraft is projected to make for a very long time afterward. Voyager 2 is heading toward the constellation Sagittarius, and in roughly 40,000 years will pass within a similar rough distance of a star called Ross 248. These are not destinations in any meaningful sense. A pass within a light-year and a half of a star is, on the scale of interstellar space, the equivalent of a message in a bottle drifting near a coastline without ever actually reaching land. Neither spacecraft is aimed at either star. Neither will slow down, enter orbit, or do anything other than continue past at the same, essentially constant velocity it has maintained since leaving the solar system for as long as the laws of physics allow, which is to say, more or less forever, barring a collision with something else drifting through the emptiness of the galaxy, an event so statistically improbable across the volumes of space involved that it barely registers as a real risk over any timescale shorter than the age of the universe itself. This raises the obvious and slightly uncomfortable question. If the golden record is not heading toward any star, any planet, any plausible audience, who exactly is it for? Carl Sagan addressed this question directly more than once in interviews and writings produced both before and after the Voyager launches. His answer, consistently, was a kind of honest reframing of the entire premise. The record was never really designed with a serious, practical expectation of being found and understood by an extraterrestrial civilization, though that possibility, however remote, was part of its justification. Sagan and the rest of the team understood, even at the time, that the overwhelming likelihood was that the record would never be found by anyone or anything at all, for the simple reason that interstellar space is staggeringly empty. Stars are staggeringly far apart, and the chances of a small 12-inch disk randomly drifting close enough to any inhabited or even just curious star system across cosmic timescales are vanishingly small. But Sagan argued that the record's deeper purpose was always at least partly aimed inward, toward the people who built it and the people who would learn about it. The act of trying to summarize an entire species, its music, its languages, its biology, its science, its emotions, onto a single disc the size of a dinner plate, forced a kind of collective self-portrait that had never been attempted before. Assembling the record required the team to ask, seriously and specifically, what about humanity was actually worth preserving, worth representing, worth being proud of, on the assumption that literally nothing else about this version of human civilization might survive to be remembered. That exercise, Sagan suggested, had value regardless of whether anyone out there ever actually heard it. It functioned as a mirror as much as a message, an instrument for understanding ourselves disguised as an instrument for reaching someone else. To understand exactly how alone the golden record really is, it helps to abandon the comfortable habit of measuring distance in miles or kilometers, and instead try to feel the scale the way the team who built it understood it. Voyager 1, the more distant of the two spacecraft, is currently more than 15 billion miles from Earth, a number that, like the distances discussed in any serious conversation about interstellar space, is almost designed to slip past human intuition without leaving a mark. 15 billion miles is roughly 166 times the distance from Earth to the Sun. It is a distance light itself takes more than 22 hours to cross. If you sent a radio signal toward Voyager 1 today, asking it a question, the answer, traveling back at the speed of light, would not arrive for nearly 2 full days. And yet, in the context of interstellar distances, 15 billion miles is nothing. It is a rounding error. The nearest star system to our own, Alpha Centauri, lies roughly 25 trillion miles away, over 1,600 times farther than Voyager 1 has traveled in nearly 50 years of continuous flight at over 38,000 miles per hour, one of the fastest speeds any human-made object has ever achieved. At its current velocity, Voyager 1 would need more than 70,000 years just to cover the distance to that single nearest star, and it is not even heading there. It is heading toward empty space in the general direction of a constellation, on a trajectory that will not bring it meaningfully close to any star for tens of thousands of years, and even then, meaningfully close means passing within little more than a light year. A gap so enormous that no plausible observer on a hypothetical planet around that star would ever notice the spacecraft's existence without specifically searching for it. This is the scale the golden record now exists within. Not a message en route to a destination, but an object suspended in something closer to true emptiness than almost anything humans have direct experience of. Interstellar space contains, on average, roughly 1 atom per cubic centimeter, a vacuum so close to absolute that laboratory vacuum chambers on Earth, built using sophisticated pumping technology specifically to remove as much matter as possible, often still contain more particles per unit volume than the space the Voyager probes are now passing through. The record is not traveling through a sparse but navigable medium. It is traveling through something that, by any practical human definition, is simply nothing for distances that dwarf anything covered by any vehicle in the history of transportation. Carl Sagan himself, in writings produced after the launches, returned again and again to a particular way of describing this scale, one that has since become one of the most quoted passages in popular science writing. He pointed out that the Voyager spacecraft, and by extension the records mounted to their sides, will likely outlast every century, every monument, possibly even the existence of our species itself and the readability of every language currently spoken on Earth. The gold-plated copper of the record itself, protected from atmospheric oxygen and from erosion by wind or water, simply because there is no atmosphere, no wind, and no water where it now travels, will not corrode the way it would on Earth's surface. Estimates suggest it could remain physically intact and, in principle, still playable for a span measured not in thousands of years, but in many hundreds of millions of years, potentially even longer than that, depending on assumptions about micrometeorite erosion and radiation exposure across truly vast timescales. Sagan suggested, somewhat provocatively, that the golden record might outlast Earth's biosphere itself. Long after the Sun has aged, expanded, and rendered Earth's surface uninhabitable in several billion years, long after whatever remains of human civilization has been forgotten by whatever remains of the universe, the record may, quite plausibly, still be out there, intact, silently carrying a heartbeat, a sunset, and the memory of a woman falling in love through a universe that no longer contains anyone who remembers any of it ever happening. There is something genuinely strange about sitting with that fact directly. We tend to think of permanence in terms of monuments, of stone, of writing carved into rock, specifically because rock seems to last. The pyramids of Giza have stood for roughly 4,500 years, and we consider that an almost unimaginable span of endurance, a structure that has outlasted entire civilizations, entire languages, entire belief systems. The golden record, by the most credible scientific estimates, may outlast the pyramids by a factor of more than 100,000. It may, in fact, outlast the very rock the pyramids are built from, since geological processes on Earth's surface, erosion, tectonic activity, glaciation, simple weathering, will eventually reduce even the most carefully constructed monuments to dust and sediment while the record drifts on, unweathered, because there is nothing in the vacuum of interstellar space to weather it. This single fact reframes the entire project in a way that the original team, working under the pressure of a 6-week deadline in the summer of 1977, could only partially have anticipated. They were not simply building a scientific instrument or even simply building a message. They were, whether they fully understood it at the time or not, building what may turn out to be the single most durable object that the human species, or quite possibly the entire biosphere of planet Earth, ever produces. Every painting will eventually crumble. Every digital archive will eventually become unreadable as storage formats change, as hard drives fail, as the institutions maintaining backup servers eventually cease to exist. Every language will eventually go extinct or transform beyond recognition, the way Akkadian and Sumerian, both represented on the record's greeting sequence, have already gone extinct and transformed beyond the recognition of anyone who is not a specialist scholar. But a 12-inch gold-plated disc, traveling through a vacuum so empty it barely qualifies as space at all, may simply continue to exist, more or less unchanged, for a length of time that makes every other human artifact look temporary by comparison. And it will do so utterly alone. No backup copy travels alongside it through interstellar space, though identical records do exist back on Earth, preserved in archives and museums, a detail we will return to. No maintenance crew will ever service it. No signal will ever update its content, correct an error, or add anything new. Whatever was decided in those 6 frantic weeks in the summer of 1977 is now permanently, irrevocably fixed. The final word on how a small group of scientists and artists, working against an immovable deadline, chose to represent the entirety of human civilization to an audience that, in all likelihood, will never exist. There is no opportunity for revision. There is no chance to reconsider which 27 musical tracks should have made the final selection, or which spoken greeting should have been included, or whether a different final image should have closed the visual sequence instead of a sunset. The record is done. It has been done for nearly 50 years, and it will remain exactly, precisely done for however many millions of years it continues to exist, drifting through a darkness with no edges and, very probably, no audience at all. While the record itself may persist for hundreds of millions of years, the spacecraft carrying it will not remain functional anywhere near that long, and the difference between those two timelines is worth sitting with for a moment, because it reveals something important about the nature of this entire project. Both Voyager spacecraft are powered by radioisotope thermoelectric generators, devices that convert the heat produced by the natural radioactive decay of plutonium-238 into electricity. Unlike solar panels, which become essentially useless at the distances the Voyagers now occupy, where sunlight is thousands of times fainter than it is on Earth, a radioisotope generator continues producing power regardless of distance from the Sun, limited only by the steady, predictable decay of its plutonium fuel source. That decay, however, is relentless and irreversible. Plutonium-238 has a half-life of roughly 88 years, meaning the power output of each spacecraft's generators has been declining steadily by a small percentage every year since the moment of launch. NASA's engineering teams have managed this decline carefully, shutting down individual scientific instruments one by one over the decades, specifically to conserve the dwindling electricity for the systems considered most essential, primarily the radio transmitter that allows the spacecraft to continue communicating with Earth at all. By the early 2020s, several instruments on both spacecraft, including on Voyager 2, an instrument that had been continuously operating since launch, had been permanently powered down, not because they had failed, but because there simply was not enough electricity left to run them alongside everything else. Current projections from NASA's Jet Propulsion Laboratory suggest that both spacecraft will likely lose the ability to power any scientific instruments at all sometime in the latter half of the 2020s, and will likely lose the ability to transmit any signal back to Earth whatsoever sometime in the early 2030s as the declining power output eventually falls below the minimum threshold required to operate even the transmitter itself. At that point, NASA's contact with both Voyager spacecraft will end permanently. There will be no further data, no further confirmation of position or status, no further communication of any kind. The spacecraft will not stop existing. They will not stop moving. They will simply go silent, continuing to drift outward at the same essentially constant velocity, carrying their golden records for as long as the universe allows, but with no one on Earth able to confirm any longer that they are even still there. This creates a strange and oddly poignant asymmetry at the heart of the entire project. The message is built to last for what may amount to hundreds of millions of years. The messenger, the spacecraft itself, will likely fall completely silent within less than 60 years of its own launch. A blink, by comparison, vanishingly brief against the timeline the record itself is built to survive. For the overwhelming majority of the golden record's expected functional lifespan, it will be traveling attached to a spacecraft that no longer communicates with anyone, no longer receives any instructions, and no longer has any active relationship with the civilization that built it. It will simply be there, a small, cold, gold-plated object, riding through the dark on the side of a machine that has become, for all practical purposes, a fossil, inert, silent, complete, and yet still moving forward. There is something almost unbearably poetic about this if you allow yourself to sit with it directly. We tend to imagine messages as things that are sent and then eventually received, with some kind of acknowledgement or response closing the loop. A letter arrives, a radio signal is decoded, a bottle washes ashore and is opened by someone on a beach. The entire emotional structure of human communication assumes, almost by default, that a message exists within some kind of relationship, however asymmetric or delayed, between a sender and a receiver. The golden record breaks that structure entirely. It was sent deliberately by people who understood from the very beginning that no acknowledgement would ever arrive within any timescale relevant to human civilization. There will be no return signal. There will be no confirmation. Carl Sagan and Andrewian and Frank Drake and everyone else who built this thing all died or will die, having sent the most carefully considered message of their professional lives into a silence that, by every reasonable calculation, will likely remain silence forever. And yet they built it anyway. They built it knowing that the act of building it, the act of asking, seriously and specifically, what about humanity deserves to be remembered, what sounds and images and pieces of music actually represent something true and worth preserving about an entire species, mattered independently of whether anyone or anything would ever hear or see the result. This is, in its own way, one of the most quietly radical ideas embedded in the entire history of space exploration. Most human endeavors, even ambitious ones, are built around some expectation of return. We build telescopes to receive light that has already been traveling toward us. We launch probes to send data back to Earth. We fund missions on the explicit promise of scientific results, economic benefit, or national prestige, all of which require some kind of return on the investment, however long delayed. The Golden Record was built on the explicit, openly acknowledged premise that there might never be any return at all. It is, in the most literal sense, an act of communication stripped of any expectation of being heard. It exists for its own sake, as a record in the truest meaning of that word. Not a record meant to be played for an audience, but a record meant simply to exist, accurately, faithfully, for as long as anything can exist, regardless of whether existing and being witnessed ever turn out to be the same thing. Not every version of this story is locked away in interstellar space, drifting beyond any possibility of human access. The Golden Record's content was never a single irreplaceable original, vulnerable to being lost forever the moment its only copy left Earth. Master copies and replicas exist in several institutions, including at the Library of Congress and within NASA's own archives, and the full audio and image content has, in the decades since launch, been digitized, studied, written about, and made accessible to the public in ways the original 1977 team had no real means of anticipating. In 2017, on the 40th anniversary of the launch, an independent project successfully crowdfunded a limited commercial reissue of the record as a boxed vinyl set, complete with the original Carl Sagan era documentation and artwork, allowing ordinary people on Earth for the first time to own and physically play a version of the same audio sequence now traveling through interstellar space, available to anyone curious enough to seek it out. This detail matters because it means the Golden Record's significance was never really contingent on it being heard by an alien civilization. It already accomplished something simply by existing as a finished object, available to be studied and reflected upon by the species that made it, regardless of what eventually happens or fails to happen 15 billion miles away and counting. The project's legacy within the scientific and cultural community has only deepened in the decades since launch in ways that extend well beyond simple nostalgia for an ambitious 1970s space program. The Golden Record helped establish an entire field of serious academic inquiry, sometimes referred to as interstellar message design, a discipline concerned specifically with the question of how to construct messages intended for audiences with no shared language, no shared sensory apparatus, and potentially no shared conceptual framework for understanding anything at all. Later projects, including a privately funded effort in the early 2000s called the Cosmic Call, which beamed radio messages directly toward nearby stars using a radio telescope in Crimea, and various subsequent proposals for what researchers call active SETI, transmissions deliberately aimed at potential extraterrestrial recipients rather than passive listening for signals from them, have drawn directly and explicitly on lessons learned during the Golden Record's production. Questions the original team wrestled with under enormous time pressure in 1977: how to establish a shared unit of measurement using only physics, how to convey biological information without relying on language, how to represent an entire culture honestly without simply flattering it, remain, to this day, central unresolved problems in the field, debated in academic papers and conferences that the original team could not have anticipated existing decades later. The record has also prompted, in the years since, a more uncomfortable strand of reflection, one that the original team themselves occasionally acknowledged. Several scientists, including the physicist Stephen Hawking in later public statements, have questioned whether deliberately broadcasting humanity's location and existence to the wider universe is wise at all, given that we have no way of predicting the intentions or capabilities of whatever might eventually receive such a message. The golden record attached to a slow-moving physical spacecraft, rather than a radio signal traveling at the speed of light, is in practice a far less significant risk in this regard than deliberate radio transmissions would be, simply because the odds of physical interception are so much lower and the information content so much harder to extract without specialized effort. But the underlying philosophical question the record raises, whether announcing our presence to an unknown universe is an act of hope or an act of carelessness, has never been fully resolved, and probably cannot be, given that it depends entirely on facts about the universe that we currently have no way of knowing. What can be said with more confidence is this. The golden record represents perhaps the purest distillation of a particular kind of optimism that defined a specific moment in the history of space exploration. A moment when scientists felt confident enough in humanity's capacity for self-reflection and hopeful enough about the possibility of connection across the most extreme distances imaginable to attempt something this audacious on a deadline this absurd. It is worth remembering that the team had 6 weeks. 6 weeks to decide what music represents the best of human creativity. 6 weeks to decide which 40 or so images could possibly summarize biology, geography, culture, and technology for an audience that might not arrive for 1,000,000 years or might never arrive at all. 6 weeks to grapple seriously with questions that philosophers and anthropologists have spent entire careers failing to resolve, even when given unlimited time and no launch deadline whatsoever. And at the end of those 6 weeks, they sealed a finished object onto the side of a spacecraft, watched it launch into the sky over Florida, and then, for the rest of their lives, simply had to live with whatever choices they had made, knowing those choices were now permanent, unchangeable, and traveling away from Earth at roughly 38,000 miles per hour, forever. There is a particular kind of vertigo that comes from truly sitting with what this object now represents. Somewhere out past the edge of the solar system, in a darkness so complete and so empty that it makes Earth's deepest oceans feel crowded by comparison, there is a small gold disk, slowly, silently continuing to exist, carrying inside its grooves the sound of a mother speaking to her child, a heartbeat, a sunset, the brainwaves of a woman falling in love nearly 50 years ago, and the recorded voice of a child, Carl Sagan's own son, who said hello on behalf of every child on Earth and who is now himself an adult well into middle age, living a life that has continued for decades after his recorded voice left the planet, still traveling, still saying hello to no one forever. He will likely die of old age decades from now, long before the record stops moving. His grandchildren may die too. Entire civilizations may rise and fall on Earth before that small voice, drifting through the absolute dark, ever has even the remotest chance of being heard by anything capable of understanding what it means. And maybe that is, in the end, the entire point. Not that the record will be found, not that the message will be answered, but that a group of human beings working under an impossible deadline decided that the attempt itself was worth making, that summarizing a species honestly, however imperfectly, however incompletely, mattered enough to do even in the face of near certain silence. The golden record does not need an audience to mean something. It already meant something the moment it forced its creators to ask what, exactly, about being human was worth preserving forever. That question did not require an answer from the stars. It only required the courage to ask it seriously, knowing that no one might ever respond, and to send the answer outward anyway, into a darkness vast enough to swallow it completely, simply because trying mattered more than the odds of being heard. If you found this strange, beautiful corner of space history as moving as I did, putting it together, do me a favor and tap that like button and subscribe if you want more deep dives into the stories behind humanity's reach into the cosmos. The ones that rarely make the headlines but say more about who we are than almost anything else we have ever built. Thank you for spending this time with me. Until next time, look up.